11. So, exercise 14J now puts everything together in one perspective where you are not only moving the graph up and down, you'll be moving it left and right. There is an amplitude, there is a period, so there's dilations. Some of it might have reflections. But now, it's not about one cycle where it fits nicely anymore. It now, you have to confine to 0 to pi. Now 0 to pi is somewhat easier to start off with compared to the next few questions where you have negative pi to 2 pi, negative pi to pi. So you have to get used to that. Even if you move it left and right, it's not going to look like your typical one cycle anymore. It could actually may look something like this, and it'll finish something like that. Okay, and that's your job now to figure out which one it looks like and how to. And I'm going to show you my method on how to draw this accurately, or at least nicer and systematically, as opposed to trying to guess it. Because most students in year 12 will start guessing it. This way may seem more tedious, but it is one of the easier ways once you get the pattern of it and you can do it a bit quicker. Okay, so here we go. What I want you to do is to copy down this question. You've got y equals root 2 sine of x minus pi on 4 plus 1. Okay? I'm going to get you to tell me again. Let's read what each and every one of these do. So here we go. What does the plus 1 tell me? Seb, what does plus 1 tell me?
Up by 1.
Up by 1. Good. If it's plus, it tells you it goes up by 1. What does x minus pi on 4 tell me, Steph? What does it tell me? Yep, tells you where the starting point is. This is what I'm saying, that most of these graphs will no longer have a starting point now because you're not drawing one cycle. But what is x minus pi and 4 responsible for? So if you got up and down, then you have left and right. And remember, with every function I've shown you so far, if you want to know if it moves left or right, let it equal to 0. So write that as your note if you've forgotten it. Okay, so I'm going to let x minus pi on 4 equal to 0, just like how I've done it for quadratics, for cubics, for square roots, for exponential functions. I've done the same thing for every one of them. Okay, so I'm going to let it equal to 0, solve for x. Now I'm adding pi and 4 on both sides. So what does this tell me? What does x equals to pi and 4 tell me? Oscar, what does it mean if I have x equals pi and 4 in the brackets here? What does that mean now?
It's to the right.
Very good. This tells you that it's moving to the right by pi on 4. Okay, so it's positive, it moves to the right. If it's negative, it moves to the left. Okay, so in your mind right now, you've got a graph that is a sine graph, which normally it looks like this, but now it's moved to the right by pi and 4, and it's moved up by 1. Okay? Now we're going to use what we understand about amplitudes and periods. So what's the amplitude in this case? Can I please have, let's go with Lauren. What's the amplitude? Root 2. Very good. Yeah, there's a root there. So we include it as well. So that means the height is whatever root 2 is. Now root 2 could be 1 point something. That's the maximum height and the minimum height. Okay, so it goes up by root 2 and it goes down by root 2. So I know the amplitude, which I'll do in green, that tells me this is the height of root 2. That tells me that from here to here is also root 2. That's what it tells me. Okay, that's what amplitude tells you. It tells you how high from the center, how high up, and from the center, how high down, or how low down. Okay? Now I've got amplitude. What is the period equal to, though? Because this is going to be key for you to sketch. I want to use the period. We call this quarter cycles. Okay, now, how do you find the period again? What is the period? Can I please have Charlotte? What's the period of this equation here? What's the period? Not 1? What's the period, Ben? What's the period of this graph? Y equals root 2 sine of x minus pi and 4 plus 1. What's the period? No, it's not. Remember the number that it's 2 pi on n. Now I always said n is the coefficient, the number times to x. What's the number times to x right now, Will? 1. It's 2 pi on 1. Goes back to exercise 14G. This is what I mean. Do your homework. It's very easy. It's the coefficient of x. Not what you're adding, what you're subtracting, is what you're multiplying to. Okay? So now you know the period is 2 pi. This is all the information. Now the hard part to this graph is not the fact that you add 1, it's the left-right. When you move the graph up and down, at least you know it's still 0 to 2 pi, it's still one cycle, and you move it up and down. It's when you move left and right, and you keep 0 to 2 pi, it looks a bit different. Okay, so before we can sketch this is how I'm going to teach you how to do it. Okay, I want you to look back at what a normal sine graph looks like. Okay, I'm going to go back to the same page, but let's have a look at your normal sine. Sine of x, okay, amplitude 1, negative 1. I draw the graph, it's a sine graph starting at 0, I go up, I come back down, and I land here. Okay, now, there are some major points that is nice, which is why you want your exact values as well. We have the starting point, 1. We have the maximum point, which is 2. We have, again, back to the starting point, which is the middle, 3rd point. Then you go to the minimum, 4th point, and you finally finish at 5th point. Now these are very key points. This is your 0, 90 degrees, 180 degrees, 270 degrees, and then 360. Those are your main angles, hence the 5 angles that you've been working. Okay? So, how we're going to use these points to help us sketch. The reason why it's nice is you know that the period for this graph is equal to 2 pi. So that means here's 2 pi. That means if I want to know this point here, what would this point be? Pi, because it's halfway, right? And then that means if I want to know this point, what's this point here then? Pi on 2, because it's half of pi. Now the nice thing is, you now know how much it is from 0, starting at 0 to this point. You know the width. This width is exactly the same as this width. This width will be exactly the same as the center of your second half of the cycle. Okay, so now, if you actually really look at this, I want you to see, you had, this is 1 over 2, this is 2 out of 2, because 2 pi out of 2 is 1 pi. Then you have 3 out of 2, and then to get 2 pi, it's 4 out of 2. Now this is nice because if I follow that pattern, that means you can follow the pattern and say, well, if you're at the center, next one has to be the maximum. The one after that has to be the center. After the center, it has to be the minimum. After the minimum, back to the center. After the center, back to the maximum. After the maximum, back to the center. And each one will be moving by pi and 2. So next one is 5 pi and 2. Next one is 6 pi and 2. The next one is 7 pi and 2. Next one is 8 pi and 2. Then 9 pi and 2. So this is nice because even if I didn't know all of these, I just needed to know the first quarter. We call these quarter cycles. So instead of finding the period, we're now finding a quarter of the period. Because if I know how far it is from here to here to get to the maximum, then I know how far it is from maximum to the center. If I know how far it is from the center to, maximum to the center, I now know from the center to the middle. Because they're in the same quarter cycles. It's the same distance. So my goal right now, and your goal, is to find out quarter cycles. That's your goal. Okay. So let's go back here. My goal is to find a quarter of a cycle. So if you know your period, take your period and divide this by 4 because it's a quarter. 2 pi divided by 4 gives you pi over 2. That's why I know the distance is pi and 2. Now, let's have a look at our problem again. Our period is 2 pi. So that means the quarter period is equal to 2 pi divided by 4. Copy that down. Okay, so that's the key step there. We're going to use this quarter period to help us sketch this graph. Okay, and we're going to use the up and left and right to figure out where the starting point is, which is what Steph said. You know where the starting point is, and you know how far the quarter cycle is, you can predict what the graph looks like. And I'll show you. Okay, so here we go. I'm going to rub off the old graph over here. And I'm going to rub off this section here. Whoops. Okay. So we're going to find the quarter cycle. We know the quarter cycle is pi, 2 pi divided by 4. So let's try this out now. So let's have a look. Let's try to sketch this. 2 pi and 4, if you simplify this, this now becomes pi over 2. So I know the quarter period is pi and 2. let's figure out where our starting point is. Now, this is the easiest one. You know that a sine graph always starts at 0. It's always used as starting point. Okay, it always starts at 0. Okay, now, you told me it goes up by 1, so that means I'm going to move up by 1. So it's here now, it's 1. And then you said right by pi on 4. So this is where my starting point is. It's at pi on 4, and it starts here. Okay, so I'm going to just draw in red so you can see. It starts right there. Now, what I know is there has to be a maximum and a minimum somewhere and back to the center. Right? Now, you know the amplitude already. You said it went up by 1. Now, how far? That's the center. The center was here, and I moved the center up by 1. So if this is the center, how do I get to the maximum? Okay, how do I get the maximum? It's your amplitude. The amplitude would tell you how much more you need to go to get to the maximum. So if this is 1, I need to add on an extra root 2. Okay, so that means my maximum height has to be at 1 plus root 2. That will give me the maximum. I'm at the center, which is at 1. Okay, now how do I find the minimum? See, the minimum would be from 1 to get to the bottom part of the graph. It would have to be down by root 2. Because that's what we said. We said from 1 to go up, it's root 2. Then from 1 down, it has to be 1 minus root 2. Okay? Now, logically, root 2, is that more than 1 or less than 1?
More than 1.
More than 1. Because root of 1 is 1, so root of 2 has to be bigger than 1. True? So it's like think about a root 3 or root 4. Root 4 is 2. Root of 1 is 1. So root of 2 or 3 has to be in between it. So it has to be bigger than 1. Okay? So that means if I did 1 minus root 2, it has to be a negative value, logically. Now see how I'm drawing these 3 lines here? This is good for you because it's a guideline. You're starting at this point. You know at some point it has to reach the maximum. Then it goes to the middle. Then it goes to the minimum. Then it goes back to the center. Then it goes back up. So all you need to know now, well, how far? How far? What's the quarter cycle to reach that point? But you figured it out. You said the quarter period is pi on 2. So if this is pi on 4 here, I need to add pi on 2 to get to the maximum. So that's what you have to work out now. You have to work out, all right, how far do I have to go across to get to the maximum? It was pi on 4, starting at pi on 4, I'm going to add on pi on 2. Now this is all about your fractions again. Pi on 4 plus pi on 2, I can actually change that fraction to become 2 pi on 4. So this is nice. Now that means that this would now give you 2 pi on 4. If I add 2 pi on 4, this makes it 3 pi on 4. So if we have to figure this out now, that means from pi on 4 to get to the next quarter cycle is add 2 pi on 4. So to get to the next quarter cycle, it has to add another 2 pi on 4. So instead of, we went from 1 to 3 pi on 4 to 5 pi on 4. So what's the next one? 7 pi on 4. What's the next one? 9 pi on 4. And that's all we can keep going. So here we go. I'm going to keep going. I'm going from 3 pi on 4, which gives me the maximum. To get back to the center, it has to be 5 pi on 4. To get to the bottom, it now has to be 7 pi on 4, which is down here. And then to get to the next maximum, 9 pi on 4, which is right at the center. Can you see what I'm doing there? Now, if I draw the graph, if I actually draw it right now, you will have this one cycle where you know this is pi on 4, 3 pi on 4, 5 pi on 4, 7 pi on 4, 9 pi on 4. But what's the problem?
The x element is between 0 and 2 pi.
Very good. See, the element we had was 0 to 2 pi. So that means your graph actually doesn't even make it to 9 pi and 4. Okay? So you know that from the center to the minimum, 8 pi and 4, which is 2 pi, it has to stop somewhere here. We just don't know where it is. Okay, we don't know where it's sitting at. We just know that it has to stop before it even reaches the center. So how do you find out where that coordinate is? You had the endpoints. This is why I'm saying there's a lot of work in this exercise here. You have to figure out when x equals to 2 pi, what is the y value? Because it could be positive or negative. When x equals to 0, you need to know what the y value is. You need to find endpoints. Okay, so what all I've done is I've just figured out the quarter cycles for you, and we can predict. Now, if this was to add 3 pi on 4 to move, add 2 pi on 4 to move across, then to move the next coordinate back, if this is the center, the next one has to be the minimum. So if it's at pi and 4, I have to subtract 2 pi and 4 to go to the left. So if I subtract pi minus 2 pi on 4, will give me now negative pi on 4. So what does that tell me? That tells me at negative pi on 4, I should have my final coordinate, which is over here. So it should reach the minimum. But what's the problem again? We said the domain only works from 0 to 8 pi. So not only does it not reach the center here, it doesn't even reach the minimum here. So it finishes somewhere down. We don't know where it finishes. Okay? That's why you need to find out when x equals 0 and x equals 2 pi. You see, there's a lot of work around there. Okay? But that's not even the hardest part. What's the hardest part? You still haven't found the x-intercepts. That's why you have to learn 14H. That's why I said 14J is a combination of everything. You've got chapter 7, you got the sketching, you got the maximum minimum. That's why I'm saying tan graphs are the easiest one to sketch. This is the most tedious. And they've thrown it away since 2006. They don't do this anymore because it's a lot of work, right? But you have to know how to do it though. You have to know how to do it because they still need you to analyze it and learn the quarter cycles, periods, and everything. Okay, so let's try this. So, what am I missing so far? I am still missing the endpoints. I don't know where they stop and start, and I don't know where the x-axis intercepts are. But at least I got the quarter cycles. Okay, so how do I find the endpoints? Let's start to find endpoints now. So I said I had x between 0 and 2 pi. So let's find the endpoints. Let's find when x equals 0, y equals 2. Now the equation was root 2 sine of x minus pi on 4 plus 1. That was the equation. So when x equals 0, you've got root 2 sine of 0 minus pi on 4 plus 1. Let's work that out. So you got root 2 multiplied 2 sine of negative pi on 4. So you see how we're using exact values again? Plus 1. Now what's sine of negative pi on 4?
Negative 45.
It is negative 45 degrees. So if you think about your unit circle, this is why I said you had to learn exercise 14E and 14F. Otherwise, you're screwed here. Okay? So let's think about it. Negative 45 degrees down here. Sine, which is the y values. What's the y value should be? What's sine of negative pi and 4? What is it equal to? Not negative half. Which finger is the pi and 4?
Root 2 and 2.
Root 2 and 2. So it is
Negative root 2.
negative root 2 and 2 because it's below the x-axis. The y values right now are negative, so it's negative root 2 on 2. So this is negative root 2 on 2 multiplied to root 2 plus 1. Now the root 2 times the root 2 gives you 2 because root 2 times root 2 is root 4. Root of 4 is 2. Okay, so you now got negative 2 on 2 plus 1, and this is so nice. You got negative 1 plus 1, 0. Now that's beautiful. That's beautiful because that means if you go back to your graph, now you know where is 8 pi on 2, 8 pi on 4, it has to be right there. It touches the x-axis because the y value is 0. This is when y equals 0, which makes the graph easy to sketch. Okay, because we know it comes down and it hits the x-axis and it finishes there. That's at 8 pi on 4, which is 2 pi. Okay, so that's what I've just figured out. I just figured out the endpoint has to finish. Now if I just delete this part here, I want to draw it again. I now know the graph looks like this. It starts here, comes up, comes down, and then it finishes at 8 pi right there. That's where 8 pi is. Okay? So that other extra dot was where it should have landed, but it didn't land. Okay, so if I just minus all the extra drawings, if I just delete all this so you can see, this is what the graph would look like so far. Okay, so we figured out that right endpoint. Now we're going to figure out the left endpoint. Okay, well, most of the time it's symmetrical, so I know it's got to be 0, but let's test it again. Okay, so now I've got to figure out the right endpoint. I had when x equals 0, let's work out when x equals 2 pi. Same drill again, y equals root 2, multiply the sine of 2 pi minus pi on 4, add 1. So let's work it out, root 2 times sine of 2 pi minus pi on 4. Again, it's going to be the same thing. You've got 8 pi, 7 pi on 4, which you know, again, it's in this quadrant. And so therefore it has to be root 2 times negative root 2 on 2 plus 1. And as you can see, this cancels out to be negative 1 plus 1, which is 0 again. Okay? So there you go. Now I know that means in your graph right now, I've just figured out when x is 0, y is 0. Oh, sorry, when x is 0, it was 0. And when x is 2 pi, it's also 0. That's what I just figured out. Okay? So therefore, if I were to sketch the graph now, it looks like this now. I'm going to rub this red section off. I'm going to rub all of this off here so we don't get too confused. I can now say that the graph finishes right at 0. There we go. Now, I've almost finished. I've got the endpoints. I had 0, 0, 0. I have 2 pi 0, which is the endpoints. I got the maximum, I got the minimum. The minimum was 1 minus root 2. Okay? And the only things I'm missing are the x-axis intercepts. Now, I already got 2 out of the 3. Now you have to figure out the x-axis intercepts. Okay, so you can see my graph so far looks like this. Looks like that, comes down and finishes. See how it's not a full cycle the way that you're used to seeing, okay? And it's from 0 to 2 pi, okay? I'm only missing the x-axis intercepts, and this is where it's the most tedious. Actually, that was the most tedious. The other one most students will pick up in year 12. Now I'm going to find the x-axis intercepts. You had y equals to root 2 times sine of x minus pi on 4 plus 1. How do you find x-axis intercepts? What do you do? Let y equal to 0. So now 0 equals to root 2 sine of x minus pi on 4. Now, just like every other thing that you've done, when you want to solve for x, you have to remove all of the other values. You want to get x by itself. So doing BUDMAS, I have to remove the additions first. Remember, BUDMAS, you start with brackets and you move all the way down to addition, subtraction. So when you're working backwards, it'll be addition, subtractions first. So here we go. I want to remove the plus 1, minus 1 on both sides. I now get negative 1. Whoops. Not that way. I've done it wrong there. You will now have negative 1 equals to root 2 times sine of x minus pi on 4. We're going to try to solve. I'm going to just remove this section here so you don't get confused there. Now, once you've done the addition, subtraction, the next one you have is the root 2. It's root 2 times sine. So I'm now going to say divide by root 2 on both sides. So we're going to divide by root 2, divide by root 2. What you end up with now is negative 1 on root 2 is equal to sine of x minus pi on 4. You're almost there. Now, this is what exercise 14H was all about. See, when I gave you guys the work, it was all about solving this. And this is where it gets tricky. You have a domain where x is between 0 and 2 pi. Okay? Now, whoops. How I taught you guys to do it was we will now ignore, we will move the domain. You know how I said if you had a 2 in front of the x, you extend the domain? I normally teach my year 12s to extend the domain if it's x minus pi and 4. Okay, so that means you're going to move everything to the left by pi and 4 just so you could fit it. But just to keep things simple for you guys, ignore the x minus pi and 4 for now. You're just going to do some trial and error afterwards. Okay, so here we go. What are we going to do from here? How do I solve? I have to do sine inverse on both sides. Got negative 1 on root 2 and the sine inverse on both sides, so these two cancel out. You got sine inverse on the left. And you now have x minus pi and 4. Your goal is not to do the x minus pi and 4. Your goal is to solve that part. And that's what I was trying to do for 14H. Trying to teach you how to solve sine of what will give you negative root 2, 1 on root 2. So think about a unit circle again. Okay, you got your unit circle. Ask yourself, when will sine be negative 1 on root 2? So where in the unit circle would you have negative 1 on root 2? Which quadrants? Yeah, the bottom half. Because you said sine is the y values. So here we go. The only two parts that you can have are these 2 points here. These are the only parts where you will have sine being negative. Because that's where sine is, the y values are negative. See, this is the y values. That's when y values are negative. So it has to be these 2 points here. Can't be up here, y values are positive. See, down here, these are the only 2 points. Now, what angle did you say? Sine of what? Sine of what angle will give you 1 over 2? 45 degrees. Okay, so you know that, okay, this had to be 45 degrees. That means this has to be 45 degrees as well. But then what's sine of 45 degrees? Which is root 2 on 2, but what's the radians? What's the distance from the outside? What's the radians? Yeah, what's the middle one again? Pi on 4. Okay, so that means this is pi on 4, and this is pi on 4. Okay, now, let's think about it. We are going to start from 0 to 2 pi. I'm going to answer the question starting from 0 to 2 pi. So think about it. I'm going to do it in black here. We're starting at 0 degrees. We're going to move all the way around the circle until I hit my first solution as my first solution. What's my first solution? It was 0 all the way here is pi with an extra pi and 4. Can you tell me from here to here is pi and 4? So pi plus pi and 4 will give me my first potential solution. Okay, so I'm going to write it down. I've got pi plus pi and 4. Then I go all the way past that circle. I go all the way and I land at 2 pi. But then I am short. I landed my first solution here. I land here, that's 2 pi. But that's a distance of pi and 4. So 2 pi minus pi and 4 should give me my second solution. Okay? Now, here's the thing. Let's work this one out. We've got pi plus pi and 4. 5 pi and 4. You have 2 pi minus pi and 4. Okay? This is all equal to x minus pi and 4, and this is x minus pi and 4. Okay? If you simplify this, 2 pi minus pi and 4 is 7 pi on 4. This is 5 pi on 4, and this is equal to x minus pi on 4. True? Here's the thing. You got 5 pi on 4, 7 pi on 4. That will work from 0 to 2 pi, right? But remember, I haven't even accounted for the fact that the graph moves right to left. That means now at the end of it, I have to take into account that it was minus pi and 4. So that's why now I'm going to move it to the right by pi and 4. Okay, so by adding pi and 4 on both sides now, I'm going to say add this by pi and 4, shift the graph by pi and 4, because we said move the graph to the right. That's why we say at the start, we said it moves to the right by pi and 4. Then now I'm going to move all these coordinates. 5 pi and 4 now becomes 6 pi on 4. And this now becomes 8 pi on 4. And so that's why I know, looking back at our graph, let's go back to our graph. We already had one of the x-axis intercepts. We had 8 pi on 4. And we're also missing this point here, which is 6 pi on 4. Okay? Now there is a small hiccup. I wonder if you guys picked up the hiccup. This is why I meant you have to trial and error. I'm missing something. So I just solved for the x-axis intercepts and I got 6 pi and 4 and I had 8 pi and 4. Good. Why didn't my solutions have 0? What was the issue? Can anyone explain to me why there's meant to be a 0? Because clearly there's a 0 here. Clearly I was meant to get 3 answers, 1, 2, and 3. But why was it that when I solved I only got 2? And that's the problem. It's not only just up by 1, it's also when you move to the right. And the scary part of right, this is why I'm saying for my year 12s to avoid making that mistake, because in year 12s that's where they don't see that last part. I teach them to change the domain. Okay, so you know how I taught you guys when it says 2x, I said extend the graph and then bring it back later. Technically, what I should be teaching you is also by saying if it's x minus pi and 4, you should also change your domain down here. Instead of 0 to 2 pi, if you had x minus pi and 4, what you should have done is instead of starting at 0, you should be minusing this by pi and 4, because that's what it says here. then I should also minus this by pi on 4. Then you'll be starting at negative pi on 4. And then you also start here, which is 2 pi minus pi on 4, which is finish at 7 pi on 4. That's the difference. Okay, so remember when I gave you sine of 2x, I told you to multiply the domain by 2, because if it's x between 0 and 2 pi, then I said if it's 2x, then you times everything by 2. So it becomes 4 pi and 0. Now, if the question in your graph had a sine of x minus pi on 4, then you should technically be doing 2 pi minus pi on 4 and 0 minus pi on 4. Why do you do that? Because if you actually do that now, it makes sense why you're meant to have the 0. See, instead of starting at 0 before, which is where we started, we went from 0 and we went all the way across, technically, you were meant to start at negative pi on 4. If you started at negative pi on 4, which is exactly this spot, you would have got your first solution. Right there, you're landing at exactly negative pi on 4, that's where you started, and that is one of the solutions. That's why that starting point would have been one of your answers. Moved around the circle, pi plus, that's your second answer, and then you land at exactly the same spot again. That's why you would have 3. Okay? Now that's how I teach my year 12s, to make sure that they have all solutions. In your case, because it might confuse you with adding and subtracting the domain, I'm not going to tell you to do that. You can do that if you want. What's the alternative? The alternative is, now that you got 6 pi on 4, you got 8 pi on 4, how do you find the previous solutions? Now remember, it's a unit circle. If you got, I'm going to do the logic here. If you got this point as 6 pi on 4, how do you get the previous answer? The only way is move backwards. Go backwards. Go backwards an extra 2 pi, because that's one revolution. If you went back another revolution, you'd get all the solutions. So in this case here, if I said minus 2 pi and minus 2 pi, so one revolution, if you minus one revolution for each one, you'll get all the solutions. And then also you get, say, add 2 pi and add 2 pi, you get all possible solutions in one end and all possible solutions in the left end. That will cover your basis, because if you did that, now if I did that, let's try that. 6 pi on 4, let's try it, minus 2 pi. This won't give me 0, this will give me another solution that's out of the domain. So we work this one out, that will give you negative 2 pi on 4, okay? But then if I did the other one, if I did 8 pi on 4 minus 2 pi, you'll get 0. And that fits in your domain. Remember, the domain was from 0 to 2 pi. This is a solution. And that's what I mean, that's the trial and error part. And that's easier for you guys. Instead of changing the domain that I've just shown you here, instead of doing that, you can trial and error. So add 2 pi on both of your solutions and subtract 2 pi from both your solutions. See if any of those answers fit in the current domain. If it fits in the domain, then you will include it. Does that make sense? Okay, I know that's the confusing part. So like I said, without 14H, if you can't do the exact values, it's very difficult. 14G and 14I allowed you to picture the graph. Move left, right, find the amplitude, find the period. That's why they were all precursors to 14J. Without any of that, you'll find 14J very, very difficult to do. Okay? So answering your question now, what does my graph finally look like? So if I just draw it quickly, it should have started at 0, it would have gone up, and the center was at 1, so reaches its maximum, comes back to the center, comes back down to the minimum, which was at 1 minus root 2, maximum was 1 plus root 2, and it would have finished at 8 pi, or 2 pi. Okay, so that means there's a 6 pi on 4, and you know that this maximum here was at, what was it again? What did I do? I drew it over here. That was 3 pi on 4. So that's 3 pi on 4. That's what your graph should look like. That's essentially what the graph looks like between 0 and 2 pi. Okay, so in order to do all that, I showed you how to find the middle, how to find the maximum, how to find the minimum. Okay, and then you have to find quarter cycles so you can split it up like that. That was what the quarter cycles were. You needed the endpoints, which is the 2 pi and 0. And then finally, you needed your x-axis intercepts. So you can see there's a lot of work there. There's a lot of work, there's a lot of reading, a lot of skills involved. That's why I said I wanted you to focus on 14E, 14F, And I gave you so far, it's about 2 weeks now, 14E, 14F, to learn your exact values like your times tables. And I gave you 14G, 14H to sketch and solve. Those are your main ones. Okay? That's 14J. All right, that's 14J. So every other question that you're doing in 14J is going to be somewhat easier because it's amplitudes 2. The ones with the root 2s, you can sort of slowly ease yourself into it. The hardest ones is when you move left, right, up and down. If you want to start off easy, do these ones. See, that only doesn't have left, right, it has only up. Only up by 1. This one's down by root 3. Okay, these ones are a bit easier because there's no left, right, and up and down. You can do either up, down, or the left, right. But if you combine them, which is that last one, this last one, that last one there, these last question 3, those are going to be difficult. But those are the ones you want to be able to do because that's the expectation in year 11. Okay? It is tedious to do. So if you want to start off 14J, just to get your feel of it, start off with the ones without the translations, without the left rights. Okay? That's where we are at. Does anyone want me to do one more, or we're pretty good? One more? No?
No, that's fine. So stupid.
Oh yeah?
I think we have time.
Okay. All right. I'll leave it to. I'll come out and help those who would like me to do another example. Okay? I'll help those. All right.